guys, and welcome back to NASA at Home, where we bring NASA home to you. Today, we're going to set our sights on the moon. The Earth only has one moon, and it's a rocky, cratered place without oxygen to breathe. And it's about a quarter the size of the Earth. Did you know our moon is the 5th largest of the over 190 moons orbiting planets in our solar system? Earth's only natural satellite is simply called the Moon because people didn't know other moons existed until Galileo Galilei, inventor of the telescope, discovered 4 moons orbiting Jupiter in 1610. The Earth's moon is the only place beyond Earth that humans have set foot. Only 12 men have walked on its surface, but we're about to change that.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable.
That can land anywhere on the lunar surface. The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
So if you'd like to be a scientist or engineer working on the moon one day, you're going to need to know a little bit more about it first.
I love to look up at the moon at night, especially when it's big and round and bright. But I just found out that the moon's light actually comes from the sun.
That's right. All solid surfaces reflect light back to us. The moon reflects light from the sun. The sun emits the light, the moon reflects it back.
So the moon doesn't make its own light. It reflects sunlight. But why does the moon change shape every night?
The moon doesn't change shape every night. What we see is the moon being lit with different amounts every night, so it appears to change shape, which we call the phases. When the moon is new, there's no sunlight reflecting off of it back towards us. That's why we can't see it. The sun is still shining on the moon, but it's shining on the other side of the moon, and therefore we can't see it. When the moon is full, the sunlight is reflecting off the full disk of the moon, and we see it as a full moon. In between those phases, the moon goes through waxing, which is increasing. It's an old word for increasing. Waning, which is an old word for decreasing. It refers to the amount of light on the moon. So as you see the moon go from full, then it gets a little less light, and so it's a waning moon. It goes through waning gibbous, waning half, and waning crescent. Then it's a new moon. We can't see it. There's no light reflecting off of it. And then it'll start to come back slowly, and it'll go through waxing crescent, waxing half, and waxing gibbous. Full moon always rises at sunset, so if you want to see a nice full moon, go out at sunset. After that, the moon rises 50 minutes later each day. So sometimes you'll see it at night, but sometimes you can see the moon during the day as well. The phases of the moon arise because the moon is rotating on its axis. Rotation is when a body rotates around its axis. Both the moon and the Earth rotate around their axes. The moon revolves around the Earth, and the Earth revolves around the sun.
Whoa, that was some rotation. So the moon, Earth, and sun work together in a system. The phase of the moon depends on how much of the sunlit side of the moon we see as it revolves around Earth. Just like the full moon rises at sunset, the new moon always rises near sunrise. But we can't see the new moon during the day because the side of the moon the sun is shining on is turned away from the Earth at that time. And that pattern repeats over and over again. Here's something you can do at home. Go outside and look at the moon every day for a couple of months. Draw a picture of what you see, then try making your own calendar that shows the phases of the moon. Before long, you'll be able to predict what phase of the moon comes next.
For more information on this activity, check out my friend Lyle's Look at the Moon journaling activity online. Once you've studied the moon, here's a great way to help you remember the different phases of the moon. Let me introduce you to the Moon Cookie Challenge. In this challenge, you'll use sandwich cookies to create the different phases of the moon. Cookies. Right. Anyway, you'll need to be able to identify key phases of the moon in order to complete this challenge. First, let's start with the new moon, where you couldn't see any light reflected off the moon at all. And then there's the first quarter, or waxing half, where the moon was growing brighter. Then the full moon, where the moon was shining the brightest. And last, the third quarter, or waning half, where you were losing light. Try this fun challenge with your family or friends. Give each person participating 4 untouched sandwich cookies, and then each person will create the different moon phases using their cookies. You can even make it a race. On your mark, get set, go. Nice job. If you want to make it more challenging, there are more moon phases you can create. Just make sure you don't make yourself sick on cookies. Now let's talk about NASA's new lunar exploration program. Anyone remember what it's called? If you said the Artemis program, you'd be correct. But how did it get its name, and why is that name significant?
50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we will discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered
if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go. We go as the Artemis generation.
We go.
So there's no maybe about it. We are going to the moon as a part of the Artemis generation. Did you guys realize that you are a part of the Artemis generation? Now, in honor of Artemis and women everywhere, I think we need a musical break.
No.
Oh, well, it says Lindsay performs. What am I supposed to think? Sorry, wrong Lindsay. Take it away, Lindsay. Let's meet one of the many amazing women who work at NASA. She's one of our engineers who works on the new Space Launch System rocket.
I'm Yvette Rivera Ponte, and I'm a project engineer at the NASA Kennedy Space Center, where I support the new Space Launch System. I grew up in Mayagüez, Puerto Rico, and I currently live in Orlando, Florida. My grandfather was the first person to introduce me to engineering, and I discovered I can combine my love for math and space in this field. I earned my bachelor's degree in civil engineering and my master's degree in structural engineering. My advice to students, never give up on your dreams.
It's funny, the moon seems a lot closer than it actually is, because we can see it fairly clearly without a telescope. We can even recognize the craters on its surface on a clear night. Often when we see drawings of the Earth and the moon, they look really close together. Don't be fooled, they're actually really far apart. The moon is an average distance of almost 240,000 miles away. How far away is that? That's 30 Earths away.
The moon is the brightest object in the sky after the sun, and it plays a big role in patterns we see here on Earth. Did you know that our moon is the reason for tides?
That's right. A tide is another word for gravitational pull, The moon pulls on the Earth, but the Earth also pulls tides on the moon. When the water is in motion, it moves towards the moon, and that gives us a tide. The tide also is important for the Earth because it moves water around. When water moves around, nutrients move around, and a lot of animals and even humans depend on having tides. A lot of us also depend on moonlight for navigating at night. It provides light in our night sky. So there's a lot of reasons that we like to have the moon around.
Cool. The moon really does have a big effect on Earth. But how do we know so much about our moon?
Well, people have always looked at the moon in wonder in our night sky. It's so bright and it's so close, and we'd like to know more about what it's made out of and how it got to be there. So NASA develops missions to the moon and to other planets to understand how we all work together as a solar system. NASA has been sending missions to the moon since the 1960s, starting with robotic missions and building to human missions. We sent humans to the moon with the Apollo missions to pick up rocks to bring back to the Earth and to learn about the moon's environment. Since then, we've been sending robotic missions like LRO and LCROSS and LADEE that have helped us map the surface of the moon. We have maps that show us the surface features, the craters and the lava flows. We have maps of temperature. We have maps of the gravity of the moon. And all of those things help us understand what the moon is made out of. It turns out the moon is not dry. It has water on it, actually, but the water is frozen. The water is frozen at the North and South Pole in deep craters that are permanently shadowed. They never receive any sunlight, so they don't ever heat up, and that water can stay frozen for billions of years. We hope someday to be able to go to that water and extract it and use it to live on the moon. Even though we know a lot about the moon, there's still so much more we want to learn.
So as long as we have questions about the moon, NASA will keep planning missions to answer those questions, because the moon is pretty important to our world.
NASA is partnering with 14 commercial companies to deliver science, technology, and research to study more of the moon than ever before. On the moon, we'll also be able to do research that will be vital to sending humans farther into space, like traveling to Mars. You can think of it like a practice space, especially since a round trip to Mars will take 2 years, but a one-way trip to the moon only takes 3 days. We are creating new and innovative technologies to land more precisely on the moon, visit new areas like the lunar South Pole, and do research.
Did you know, here at NASA Langley Research Center, Neil Armstrong practiced for landing on the moon on the simulated lunar surface at our Lunar Landing Research Facility. Today, NASA has selected 3 U.S. companies to design and develop new human landing systems for the Artemis program, one of which will land the first woman and the next man on the surface of the moon by 2024. NASA is on track for sustainable human exploration of the moon for the first time in history. And the companies are SpaceX, Dynetics, and Blue Origin.
Landing on the moon and Mars is tricky. A lander headed to the moon can go as fast as 24,816 miles per hour. Those on their way to Mars might go up to 13,000 miles per hour. To land gently, these spacecraft need to slow down before touching the surface. And if there's astronauts on board, the lander needs to keep them safe too. You can build your own lunar lander with things you can find around your house. NASA challenges you to design and build a shock-absorbing system that will protect 2 astronauts when they land. Now, here are the suggested materials for this activity, but don't worry if you don't have all the materials. Get creative and substitute materials with what you do have. It's all part of the design process and being a real engineer. Just be sure to choose your materials and then only work with the materials you chose. That's part of the challenge. So you'll need some scissors, a piece of stiff paper or cardboard, and a cup. Paper, plastic, just a disposable cup. And then you'll need 3 index cards or 3 pieces of paper that are the size of index cards, so about 3 by 5 inches. You'll want 2 marshmallows, regular size, and 10 mini marshmallows, and 3 rubber bands, and 8 plastic straws. along with some tape. You'll need about 1 meter of tape, so 39 inches approximately. Now, once again, if you don't have any of these materials, get creative. If you don't have a marshmallow, maybe try using some Play-Doh or some cotton balls. Now, think about what you do have around the house that is okay to use, and you can replace those with the things that you see here. Just as engineers had to develop solutions for landing different kinds of vehicles on the moon and Mars, you'll follow the engineering design process to design and build a shock-absorbing system out of simple materials and improve your design based on the results of your test landings. Consider how you will softly land your astronauts, aka your marshmallows, using the allowable materials. What kind of shock absorber can you make from these materials to help soften a landing? And how will you make sure that the lander doesn't roll while falling through the air or tip over when it lands? The 2 regular marshmallows must be inside your cup. The cup has to stay open, no lids. Sketch your design and assemble your lander. Drop your lander from a height of 1 foot or 30 centimeters. If the astronauts, aka your marshmallows, bounce out or the lander tips over, figure out ways to improve your design. Study any problems and redesign. Then test again to see if your new design solved the problem. Drop your lander from progressively higher heights, 2 feet, 3 feet, and so on. As problems arise, study them and redesign. Then, test again. Share your design with NASA. Snap a picture or video of your spacecraft and post it on Facebook, Twitter, and Instagram using the hashtag #VirtualMoonshot. Be sure to get your parents' or guardians' permission before sharing your snaps online. Or ask if they can post it for you. I can't wait to see what you guys come up with. Remember, you could be the designer of robotics on Mars or other planets someday. Best to start practicing now. For more information about this activity, you can check it out online with Lyle. Now that we know how to get there, what will it actually take to live on the moon?
We've lived on the Earth for a long time, and we've gotten pretty good at it. In fact, we've gotten so good at it that we've started thinking about living somewhere else. Somewhere like another planet, or even somewhere as close as our moon. Now, one of the reasons we're so good at living on the Earth is that it has pretty much everything we need. Somewhere like the moon doesn't. So if we want to live on the moon, we're going to need to take a few things with us. And what are the 3 basic things we need in order to live? That's right, food, water, and air. Let's start with air. The moon has none. Humans need a combination of gases in order to breathe like we do here on Earth. So what happens when we start running out? We can bring more, but that gets expensive. So we need to find a way to make some more on our own. How about adding some plants? Plants take our carbon dioxide and convert it into oxygen. And as a convenient byproduct, we can eat them too. That helps solve our food problem. But we're forgetting one thing. Both humans and plants need water. We'll bring some to start, and we've come up with some clever ways of recycling it. That can keep us going while we search for water or ice. So we have our food, our water, and air. What else do we need to deal with? That's right, the sun. The sun helps plants grow, and we can use solar panels to give us power. But too much sun can be dangerous. On the Earth, we're protected by our atmosphere, so we get just enough sunlight. But on the moon, there is no atmosphere, so we need to protect ourselves from all that radiation. So now we're living happily on the moon. But what happens when we want to do something like order pizza? Well, on Earth, we just pick up the phone. We can do the same thing on the moon, but it's not that simple. We need satellites to make that call. But seriously, folks, our scientists on the moon will be doing more than just ordering pizza. They'll be sending lots of information back to the Earth so we can learn more about our new environment. And when it comes to living in space, the more we know, the farther we can go.
Living on the moon won't be easy, and neither will be traveling away from our home planet. Sometimes I think we forget how truly dangerous and challenging space exploration can really be.
Space travel is hard and unforgiving. It's always been and always will be.
It's going to be hard. There's a new chance of death. Going in a little can through deep space, it's a very harsh environment.
We think you can come back, but nothing is certain.
There are all sorts of challenges we will face on deep space missions. Communication delays, radiation protection, isolation of the crew.
So it is not surprising that some would have us stay where we are.
There's never going to be zero risk. When you're breaking the bonds of gravity, that's just part of the deal.
And it is one of the great adventures of all time.
Okay, all flight controllers, go for landing. Retro, go. Fido, go. Guide, go.
That challenge is one that we're willing to accept.
Surgeon, go.
Man in his quest for knowledge cannot be deterred.
Space is not just a destination. It changes you forever.
It'll be tough, really tough, but we have the right people for the job.
We have pressed the qualities for success into system after system.
This country of the United States was not built by those who waited and rested.
Pushed our people past every failure we can dream up.
We have never been more ready to meet the unknown.
Through Artemis, we will once again explore beyond our world.
And we will succeed.
Thanks for joining me for NASA at Home, and don't forget to check out other activities on NASA STEM at Home for students. See you next time!